Hi, I'm Chapesi.
Hi, I'm Divyasri.
Hi guys, so I'm Cindy.
My name is Alia Sabrina binti Zulkarnain.
And my name is Xiaohui, and this is our introduction of biosensor.
As for the introduction, there are two main harmful substances in this study, which are catechol and resorcinol. Catechol is autoisomer of benzediol and found in lubricating oil, photographic developer, and also pharmaceutical. Resorcinol is meta-isomer of benzediol and found in manufacturing industry, phenylglycine, and also pharmaceutical. Major producers for this substance are gasification and carbonization industry, which they releases those chemicals inside wastewater, and it is toxic and carcinogenic to human and cause serious impact to wildlife and also environment. To detect those chemicals, conventional method like spectrophotometry and chromatography is used. However, it is sophisticated and time-consuming and required qualified staff. In this study, it will use wetman filter paper as it is have advantages over the conventional method, which it have large pore volume to support the lateral flow, and biorecognition agent like enzyme can be immobilized on the paper by physical absorption and also covalent coupling or polysaccharide entrapment printed on the paper using a piezoelectric inject printer. This objective in the study is to detect catechol and resorcinol using wetman to compare and evaluate the best immobilization method that could detect catechol and resorcinol. So the mechanism for the wetman is that the analyte will attach to the enzyme, which is horseradish peroxidase, and causes changes in pH and gives electric signal.
Hi, I'm Chapesi. I'm going to talk about the application of enzyme-based biosensor. So the benefit of the enzyme-based biosensor are point of care diagnosis testing, possibilities for miniaturization, high sensitivity and specificity, fast and precise, cost-effective, and portability. So the enzyme-based biosensor can be applied in clinical analysis, food safety control, disease monitoring purpose, and environmental monitoring. The electrochemical enzyme-based blood ATP and lactate biosensor was used in the clinical analysis in real life. So on the left-hand side is the diagram showing the overall how the biosensor works. On the right-hand side is the simplified version of how the biosensor works. So the analyte is the blood where it contains ATP, ascorbate, ADP, urate, and lactate. This analyte will bind to the bioreceptor on the biosensing element, which is the enzyme. So the binding between the enzyme and analyte will transmit a signal through transducer, which is microcontroller, and lastly produce an electrical signal which contains lactate and ATP level. So the ratio of the lactate to ATP level was used to provide an alternative illness severity score.
Hi, I'm Divyasri. I would like to explain on the immobilization method. First method is the physical adsorption of HRP on wetman paper. So basically we use 200 mg per ml of HRP concentration. We transfer that to a filter paper and then we let it dry for 30 minutes. So after that the paper is washed with 3 times with 100 ml of washing buffer and dried again for another 30 minutes. And then we use the volume of solution content catechol, MbPTH, hydrogen peroxide at the pH 6, and then we transfer the solution to the same paper and observe for the color development. So the result is scanned for every 50 minutes after the catechol dispension, and they use image software to analyze the result. So the next method is HRP and treatment in chitosan. The steps are still the same, just that in this method the difference is that they use the chitosan gel mixture. So actually the chitosan gel mixture contains a phosphate buffer, and HRP enzyme, and glutaldehyde as a cross-linking agent. So after the mixture is stirred, the mixture is then placed on the filter paper square and let it dry for 30 minutes, and then it washed with the washing buffer which contain 2020, and then the steps are followed as similar as the physical adsorption method.
Hi guys, so I'm Cindy. Now I want to explain about the HRP immobilization by the covalent coupling on the Whatman paper and also the chitosan paper. So for the Whatman paper, we firstly introduce the glutathione in the phosphate buffer in the original paper, followed by the washing with the mixed solution of the buffer, and then we add the enzyme solution in the coupling buffer, and again we wash with the buffer solution, and finally we add the solution containing of the catechol, MBTH, and also the H2O2 hydrogen peroxide. This is briefly the step for the Whatman paper, while for the chitosan, just one more extra step, which is addition of the chitosan solution and allowed to dry, and now the chitosan paper is ready to use and proceed with the step that I explained just now in the Whatman paper. Yeah, so this is briefly how the step in the HRP immobilization by the covalent coupling. Yeah, so next is about the comparison on the color intensity for all the methods. So we can see from the graph that the physical exertion and the entrainment show the higher intensity indicates that they are relatively more efficient, and there are a total of 3 factors will affect the inefficient immobilization of the covalent coupling, which are incubation period, excess glutathione, and also no primary amine group on the Whatman paper. After the comparison with the color intensity, the researcher also do the comparison on the stability. We can see from the graph that the chitosan entrapment is more stable in both after 30 minutes and also 24 hours. So we can do the conclusion is the chitosan entrapment is the best method among these 4 immobilization methods.
So actually, we found the biosensor with HRP is immobilized in various methods by changing medium, like using chitosan, covalent coupling rather than physical absorption. In the common studies, HRP was found to be not only be immortalized by the method stated, but also can be repaired with mediator like protropinon, mediator-free or enzyme-free electrode like hemoglobin and nanoparticles. In the research, the reason only HRP contained electrode was prepared to counter interference from other elements, which affect detection efficiency. Thus, mediator was added to quicken the detection process and prevent interference with other elements like oxygen. But still, mediator-free or enzyme-free biosensor was wanted to be further modified and was preferred to provide a simple and direct electrochemical reaction and preparation to reduce the toxicity from mediator. In this case, alternative modification was shown on the hemoglobin protein, protective polymers, and nanomaterials used in the research until today. However, in the end, nanomaterials is more preferable to use as it has more surface area to contact with electron.
As per the conclusion, chitosan entrapment with glutaraldehyde cross-linking is efficient method for immobilization of enzyme. Advantages are it requires less volume and concentration of enzyme, it is time-saving, easy, and it does not require layer-by-layer deposition, cost-effective, portable, disposable, and stable, which can cater the market demand.